Hi guys, welcome to a series of videos for Form 2 General Science, and today we're going to start with video number 1, which is going to discuss magnetism, right? So I've designed the revision topic of magnetism according to about 5 or 6 questions that will take you through the whole topic. So the first thing we're going to discuss is the magnetic field pattern around a magnet. So your single bar magnet normally consists of your field lines going out of your north pole. They go into the south pole and they will go from north to south. Now actually, if you want to consider within the magnet itself, the field lines will go like this. Internally, it will go from south to north. So inside the magnet, they will always go they will follow the field lines at the ends, but on the top and bottom, they will go from the north all the way to the south. What magnetic field exists between like poles and unlike poles? Okay, so unlike poles attract, like poles repel. And again, that has to do with how your field lines move. So your field lines will go out of your north into your south. They will go from the north to the south. So based on the direction of how your field lines operate, they will consist of one of attraction. In the same way here, you will notice that like poles repel. So what you will do is that you will find your field lines not being able to follow each other when you consider like poles. So when you do not have them meeting or following each other, then that develops into a repulsive force. Remember, field lines are lines of force. So the interaction of these field lines is what will govern an attractive force or a repulsive force. What does the internal structure of a magnet look like? Okay, so when we talk about the structure of a magnet, we are talking about the magnet consisting of a series of domains. So if you have domains, a domain is actually in itself considered a tiny little magnet, and that is represented by an arrow. So the top of the arrow would represent the north and the base of the arrow represents the south. So when you have a series of these domains contained in your magnet, your unmagnetized material has your domains randomly arranged. But when you begin to magnetize that material, it causes the alignment of those domains. So all of the arrows will point to the north, and then the base of the arrows will point to the south. So when the domains become neatly arranged, neatly aligned, that is what we consider to be a magnetized material. But if the domains are haphazardly arranged, that is called an unmagnetized material. What happens when you drop or heat a magnet? Well, when you drop it or you heat it, it basically means that the domains become misaligned. They no longer maintain that neat, orderly arrangement, but you end up having them reverting to a very random arrangement. And that results in the material or the magnet becoming unmagnetized. Now, when it's heated, the domains will become excited, and that also contributes to them becoming randomly arranged. What happens when you cut a magnet? Well, if the magnet is broken or for some reason it's segregated, you have two separate magnets being formed. What is an electromagnet? Okay, so an electromagnet is one where the coil of wire is wrapped around a soft iron core. So what you will find is that when you have a current through the wire, there is a rule in physics, right, and general science, where once you have a current flowing through the wire, there is a magnetic field being generated. So here you would basically see that you have your core, which is just like iron, and when you wrap your wire around it and you have a battery, it would result in a magnetic field, and you have the iron nails and stuff becoming attracted to the electromagnet. Now the thing about the electromagnet is that it is temporary magnetism. So if it is that you switch off the current at any point in time, then you do not have a surrounding magnetic field.